Welcome to another lecture on R. Today we're going to talk about data frames. Data frames are the primary and best way to store data in R. They effectively look like spreadsheets and they allow the user to access and interact with the data very easily. Data in a data frame looks sort of like what a spreadsheet would look like, where each column represents one attribute that you measure and each row represents one subject that you've measured. So here we've got in row 4, we've got a particular tree, and this tree has a girth of 10.5, a height of 72 feet, and a volume of 16.4 cubic feet of lumber. So each row is an observation, and columns are attributes on that observation that have been measured. Now, one of the best things about data frames is the fact that these columns have headers, right? I've got a column named here for girth, a column named for height. Unlike, say, Microsoft Excel, anytime I do a calculation with R, I'm not going to refer to the column location. I'm not going to refer to column A, column B, column C. I'm actually going to refer to girth and height. And so if I want to do calculations, I'll use calculations that or the name of the column, which makes sense. This makes it far less likely to make errors in my calculations because I know the names of the columns. The first thing that we want to know is, how do I get data from, say, a package or from a file? To get data from a package, all we have to do is have the package already downloaded, which we can do by going over to Tools, Install Packages, and make sure that the package is installed. And once the package is installed, all we have to do is load the individual data frame that we want from the package that we want. So this command data will load the alfalfa data set that lives in the package fairway. So let's go ahead and do that. And now I have this data frame over here called alfalfa, and I can click on it, and we see that each row represents an observation, and then each column represents some aspect of that. In this case, a shade treatment, an irrigation treatment, inoculum, and then the yield from that observation. So importing data from a package is relatively easy. If we want to import data from, say, a file on your computer, that's actually relatively easy too. So here we're going to talk about a comma-separated values file. So I can use this read.csv file to read in what is a comma-separated values file. Now, the assumption is that this file lives in my current working directory, which in this case is this directory right here, this down here. If we want to read in a file that exists elsewhere in our computer other than our current working directory, all we have to do is tell R where to find it. So you could do this by giving the full path to the file. So for example, maybe I want to go to my home directory. On a Mac, your home directory is this squiggle. And now what I'm going to do is I'm going to use tab completion. And when I hit tab, it brings this drop down menu here, and I can sort of select things from here. So I'm going to go to Dropbox, I'm going to hit tab again, and now within Dropbox there's all of my things that I could have. NAU, and I'm going to go to my research folder, and then I can go to a particular file that I want and go to the data and read in an Excel file. Now for both of these Excel files and CSV files, I assume that the first row is the header information and everything else is actual data, and it looks nice that way. If you want to know more about loading data when it doesn't look quite this nice, we'll have another lecture on that later. But for now, this will give us a way of reading either CSV files or Excel files. In a data frame, every cell in a column has to have the same type. So in this data frame, you can see that under the name column, all of these names are character strings. Salaries, these are all numbers. The teams are actually a factor because there's only a certain number of Major League Baseball teams. So this is categorical, and likewise the position is categorical. In general, most of the variable types that we've got in R, they are pretty self-explanatory with the exception of factors. So let's talk about factors for just a second. So factors are what R calls categorical variables. Now in this example, I'm going to make a simple little data frame with a column Y, and I'm going to notice that Y is a factor because I called it a factor using this function factor, and it has levels A, B, and C. R is going to store this factor not as A's, B's, and C's, but rather R chooses to store that the first two observations are from group 2, the next two are going to be from group 1, and then the last one is group 3. And so R is actually just going to store the group assignments, group 2, group 1, group 3. And implicitly, it also keeps around this mapping that is which group it is to what the label is that you're going to show. And so as a result, if I need to do something where I relabel my columns, so instead of maybe A, B, and C, I want to refer to Albuquerque, Boston, and Charleston, then all we do is we modify this mapping between group 1 and the label it is. So as a result, there's two tricky things that could happen. If I grab my individual column, my data Y here, if I grab it and I say, hey, take this factor and turn it into an integer, what it'll do is it'll spit out these levels. And so it'll spit out group 2, group 1, 1, 3, and these are now numbers. But if I ask for it as characters, it'll spit out the actual labels of it. So it'll spit out the B, B, A, C. This is something that can trip people up if you're not aware that R actually has this mapping behind the scenes from the group assignments to the group labels. Next, we need to be able to do some basic manipulations with a data frame. So first off, let's create a data frame. Now, creating a data frame by hand is something that I need to do sometimes while I'm teaching, or sometimes I need to do something clever while I'm making a graph. So typically for actual data, I read in from a CSV file or an Excel file, but sometimes I need to make it by hand. So in this case, I'm going to create a data frame that has the family information from my family. And you can see that we've got Derek, Aubrey, Elise, and Casey, and we have our individual ages, and we have our heights in inches, and you can see it's 2 adults and 2 little kids. One nice thing about this is that when I use this data.frame command, what I do is I specify the individual column. So I'm going to specify a column for names, a column for age, and a column for height. But when I look at this in my code, it's not clear that this height 43 inches corresponds to Elise, because it's hard to view this because the names take up more space than the heights. To get around this, I can use this function called tribble, which is going to lay out the exact same data frame, but now we're going to specify things via rows, not specify it via columns. So now I'm going to look at the first row, which is for Derek and his age and his height, which is me. My wife, Aubrey, her age, her height. My daughter, Elise, her age, her height. So now this is much more readable in terms of whose height and age are whose. So I actually prefer, when I create a data frame by hand, I'm going to use this command called a tribble. And the R here stands for row-wise, and the rest of it stands for the fact that this is a tibble. Now a tibble is just a data frame with a few quality of life improvements. We'll talk about that later, but you can think of it as just sort of a fancy data frame. The next thing that I want to do is I want to be able to access particular rows and particular columns in my data frame. So the most common way to access columns is going to be using this $sign notation. So in order to address my family, notice that over in my global environment, I've got this family object, right? I don't have names, I don't have ages, I don't have anything else. I just have this family. So in order to access a particular column, I need to specify what data frame I care about and then what column I want. So this family $names will give me the names column within the family data set. Likewise, family $age gives me the ages. Now this is just a vector of numbers, so anything that I can do with a regular vector, I can do with this vector that happens to be nested in a data frame. So if I want to calculate the mean age, I can happily do that just using this family $age. Now this isn't the only way that I can access elements of a data frame. The other way that I can do it is using what I'm going to refer to as square bracket notation. Now in square bracket notation, we always specify the rows first and then the columns, and that's just convention. So you have to remember rows, then columns. Now, if you don't specify anything for either the rows or the columns, R is going to implicitly assume that you mean all of the rows or all of the columns. So if I do family square bracket and then nothing for the rows, and then specify that I want the column names, this will give me the column names, and it'll give me all of the rows within that column. If I want a particular row, in this case row 2, all I have to do is specify that I want row 2 column names, and that'll give me Aubrey's name. Likewise, if I want all of a particular row, I could just say give me row 3 and all of the columns. Now the last thing that I might want to be able to do is I want to be able to update individual elements within a data frame. So I'm going to use my square bracket notation here, and I'm going to change row 3 column 2, which is Elisa's age, and because she just had a birthday, we should update her age from 6 to 7. And we'll do this just by assigning the value 7 to the element in 3-2. And we've made a modification only to this one cell. Everything else stayed the same. Now I might want to add a new column, an entirely new column. So what I will do is I'm going to take my family height in inches, and I'm just going to multiply it by 2.54, and that'll give me my family's heights in centimeters. Now, in order to create a new column, I'm just going to take this new vector that I'm going to calculate and create when I do this calculation, and I'm going to save it in my data frame $, and then give it the new column that I'm interested in. So we're going to make a new column called height.cm, and that is going to be calculated here. And there we have it. We have a new column here. So that's basic manipulations of a data frame. In the next lecture, we're going to talk about basic graphs using a data frame, using my favorite package, ggplot2. See you next lecture, and have a good day.